What observable change occurs when you add bromine to an alkane? Does the container turn colorless or does it turn brown? That is 4.1.2. But let's just go ahead and do 4.1.1 first. The question is saying that which type of addition reaction is reaction 1? So let's go ahead and do some analysis. So we have reaction 1 here, and we are adding Br2, right? So we know that it is an addition reaction, but what is the name of that addition reaction? Because you are adding Br2, the name of that addition reaction will be bromination, right? So our answer for 4.1.1 should be bromination. Right? If we were adding 2 hydrogens, then the answer would be hydrogenation, but then here we're adding bromine, so it is bromination, right? And then now 4.1.2, one observable change that occurs in the container during the reaction. So when the reaction takes place, the color will go from brown to colorless. It will actually go from brown to colorless and not the other way around, right? So the answer to 4.1.2, the color of the container will go from brown to colorless, right? And then 4.1.3, the structural formula of compound Q. So we have compound Q right here, and then when we add Br2, one bromo is going to be on the first carbon, as we can see here from the name, and then another Br will be on the second carbon, right? So there was a double bond there. If we're adding them there and they go and stay in that location, it means that there was a double bond there, right? So we're just drawing this the structural formula of this structure right here, but then instead of putting bromo on the first and second carbon, we're gonna put a double bond, right? Because that is compound Q before we add Br2. So what am I saying? I'm saying we have 1, 2, 3 carbons for propane, and then on the second carbon we have a branch which is methyl, right? So we need only 1 carbon here, and then now we say that when we add Br2, one Br will be on the first carbon and the other Br will be on the second carbon. So there used to exist a double bond there before we added Br2. So we're going to have a double bond here, right? And then everywhere else we can fill it out with hydrogens, right? So we need a hydrogens, it's saturated, and then 1, 2, 3, 4, that one is okay. And then the one in the middle, 1, 2, 3, 4, that one is also fine. So yes, this is the structural formula of compound Q, right? And now let's consider reaction 2, 4.1.4. let's write down the IUPAC name of compound R. So let's go ahead and do some analysis again. So compound R is from compound Q, right? We add HCl in compound Q to get compound R. It is a bit confusing when you don't have a structure to actually come up with the name, right? So let me just go ahead and draw the structure, and then I can come up with the name. So let's copy this structure right here for the sake of time, and we're just gonna use that. So let's put it here. Yeah. So now that we add in HCl, this double bond, we're going to lose this double bond, and chloro is going to come here and hydrogen is going to come here. Hydrogen goes where there is the highest number of hydrogens, and then the halogen will come here in the middle because this carbon is bonded to the least number of carbons compared to this first one here. So this is the structure we're going to have at the end for compound R. So for this structure, we then need to give the name, right? So we know fully well that it is propane. We know fully well that it's going to be propane. And then on the second carbon, we have chloro, and then we also have methyl, right? So we're going to have 2-chloro-2- methyl. Yeah, it started to look messy there, but you can see what is going on. So we have 2-chloro dash 2-chloro dash 2-methyl propane, and that is the answer to 4.1.4. that is the IUPAC name of compound R, right? It's easy to make a mistake when you're naming. Let me just make sure that I'm not making any mistake. So on the second carbon, I have chloro, right? And then on the second carbon again, I have methyl, and then propane. We don't have to separate our letters with a dash. So yeah, this looks fine because I cannot say 2.2 di something because I have a chloro and a methyl. If I had 2 methyls, I would say dimethyl. If I had chloros, I would say dichloro. But then I think this one is just gonna be like this, right? And then 4.1.5 for reaction 3 right down there. So let's go ahead and look at reaction 3. We have 2-chloro 2-methyl propane turning into alcohol. So that is a saturated compound to a saturated compound. That is a substitution reaction, right? So let's go ahead and write a balanced equation for that reaction that takes place. So 2-chloro 2-methyl propane, we already have it here. So let's just go ahead and copy it again. Yeah, there we go. Let's see if we can pull it down. Yeah, we're good to go. We're good to go. So now I just need to remove these. Right, so there we go. We have the reactant in reaction 3, but we need to add something here that is going to remove this Cl, right? So what are we going to add? We're going to say, let me move it on the side just a bit. So we're going to say plus NaOH. We want to replace the Cl with an OH, but where will the Cl go? It will come here to the Na, right? So ultimately we're gonna have this will be our product. So this same structure again. So 1, 2, 3 carbons. We have a branch there, and then in place of Cl we now have OH, right? And then hydrogen, hydrogen, hydrogen. And then we need to fill out our hydrogens, and we're gonna have plus NaCl, right? And then we're good to go. You can use NaOH, you can use KOH. What else can you use? Yeah, you're not only restricted to NaOH, you can use other things too, right? And then 4.1.6, we need the IUPAC name of the alcohol. So then OH it's on the second carbon, right? So it's gonna be propane 2 all, and then now we just need to put the branch in our IUPAC name. So we're gonna have 2-methyl propane 2 all, and we are good to go, right? 4.1.7, we are looking for the type of elimination reaction in reaction 4. So we're starting with an alcohol and we ending up with an alkene. That's dehydration. So we have dehydration. We're removing an OH and then H, right, to get that double bond, right? And 4.2, we have 4.2.1. So butane 1 all reacts with propanoic acid in the presence of a catalyst, rather than the type of reaction that takes place. So as soon as I see an alcohol and an acid, I'm thinking esterification. And then now we need the IUPAC name of the organic product formed. So the first part of the name will come from the alcohol, and the second part will come from the acid, right? So because you have butane 1 all, it will be butyl, and because you have propanoic acid, it will be propanoid.